Alrighty.
Wait, are you handing out the practice test?
We'll go get practice.
But to remind me to tell you about something later.
We did them.
Yeah.
We did the last one. Alright, starts just like the other ones. How do we change this into degrees?
Multiply by 180.
Yep, so that should be 72, I think. Alright. Now, the one that's a little work, we gotta change into radians. How do we do problem number 2? We're gonna change this into radians. Pi over 180 equals what over 100? And then what do? Cross multiply. End up with 180x equals 100 pi. Someone was in here this morning having a little bit of trouble with that. Remember, you're solving for x, so you're going to divide by 180. And then we'll reduce our fraction. So now I have 10 over 18, which is 5 over 9. Right? Now we have 125 degree angle, radius is 6 centimeters, and we want to find the arc length. So when you read that problem, remember it's going to look like that on the test paper. Worded exactly the same. You should think arc length equals radius times radians. Because that will remind you that the angle has to be in radians. So we will do what we just did and change that angle into radians. So pi over 180, something over 125. Okay, now don't cancel any zeros out this time. Can't do that, right? So let's see, 5 goes into both of those. So 5 goes in 25 and I think 36. Are we done? Nope. This is when we're done. So our radius is 6 over 1. And our radians are 25 pi over 36. We've talked about this a lot the last couple days. In a multiplication, we don't do a common denominator, but we can cancel if we can. So see that 6 right there? He's going to cancel into that 36. We're going to end up with 25 pi over 6 centimeters, because that's the original number. You could also multiply straight across and get 150 pi over 36, but then you would have to reduce that. All right, that's a 2-step problem. 2 steps. Okay, number 4. We are going to find everything. So we have to find sine, cosine, and what did I tell you yesterday? If you don't like these thetas, you can always change them, right? You don't like them. Now you're going to draw a triangle. Read the problem carefully. say about the angle? It's in between 270 and 360, which means it's there. The cosine, which is adjacent over hypotenuse, is 2/3, which means the other side will be, you figure it out. What's the other side gonna be? Square root of 5. Be really, really super careful though, it's actually negative square root of 5. Did you catch that? You get sick of me saying it, but you have to remember, as soon as you draw a triangle someplace other than quadrant 1, you must have some negatives in there. All right, here we go. Sine is opposite over hypotenuse. So cosecant is the flip of that. Tangent is opposite over adjacent. So the cotangent is the flip of that. And the secant, of course, is the reciprocal of the cosine. All right, now we have to find the exact value. That one. This one. When you, the first two problems here, we have this kind of notation. What does that mean when we see that kind of notation? We're looking for an angle. So our answer is going to be something like 45 degrees or something, right? It's gonna be our angle. So, draw a picture like I always do. That's a positive number, so I will draw my triangle in quadrant 1. The tangent is 1, I'm gonna make that 1 over 1, so it's a fraction, because tangent is opposite over adjacent, so I need two numbers. So opposite and adjacent are 1 and 1. Recognize that triangle? How big is this angle? 45 degrees. So the answer to the problem is 45 degrees. This is exactly the same problem, but that's a negative number. So I will tell you what quadrant to put that in. If it's negative, I'm not going to tell you if it's positive. You know if it's positive, it's 1. This is a quadrant 2 angle. Which means, by the way, it has to be between 90 and 180. The cosine is adjacent over hypotenuse. So that's a 1. This one. You should recognize that triangle. How big's the angle right here? 30. Now, remember what we said about our answer? It has to be between 90 and 180. So don't say 30. The angle we want is this one. The one that makes that 30 over there. Well, how big would that be then? What is the answer? 150. Why is the answer 150? Because this is 180. And I'm 30 short of 180. I want to know what makes it 30 here. That would have to be 150. If you have a negative number in one of these problems, I will give you a quadrant. All right. This is a different notation now. This time I know my angle and I'm trying to find my tangent. All right, so what do I do first with these guys? figure out how many degrees it is. So this would be plugging in 180. I got 270. Uh-oh, where's 270? On the line, it's right here. So circle. Radius is 1. What are the coordinates of this point? Straight down from the origin, that would be 0, -1. So x is 0 and y is -1. And then we know, and it will be on our sheet we get, the tangent is y over x. So if we put y over x, we get -1 over 0, which is undefined. We write undefined. What if it was 0 over 1? 0. All right, same thing. Rinse and repeat. This is 150, right? However, this time, we're not on the line. This time we're out here. So we'll make a triangle this time. If this is 150 and this is 180, how big is this? 30. So this is 1, 2, √3. Negative √3. I want the sign. Opposite over hypotenuse. Did you get 1/2? If you did, you are right. 2 more. We're going to do it exactly the same. So cosine 7 pi over 4 and cosecant 7 pi over 6. So we'll start it the same way we did before. We'll change it in 2 degrees. So remember how we do that? We put in 180. So 315. So where is 315? Right here. So we make a triangle. We only do circles if we're on a line. Otherwise, we're going to make a triangle. So if that's 315 and all the way to here is 360, what's this right here? 45. So we know our sides, right? 1, 1, √2. Negative. I'm not going to be able to remind you when you take a test. You have to remember. As soon as you draw it somewhere other than quadrant 1, there must be a negative in there. All right, what do I want? Cosine. Oh, guess it didn't matter. I get 1 over √2 as my cosine. All right, last one. Hopefully you're getting good at this. Cosecant 7 pi over 6. 210. Down here. Everybody got it in the right spot? Okay, if that's 210, there's my triangle. And my angle is 30. Because 180 to 210 is 30. So 1, 2, √3. How about negatives this time? Negative, negative. Cosecant. Reciprocal of sine. So it's hypotenuse over opposite. I got -2 as my answer. Did you? now the kind of tricky one. What does less than 0 mean? Less than 0 means you are negative. So the secant's negative. Oh, and so is the tangent. All right, so which one do you want to do first? It doesn't matter. Pick one. We got to just one at a time. You got to figure out where one of them's negative. Which one do you want to do first? Secant. Secant is the reciprocal of the cosine. And cosine is associated with, oh, it's snowing, big flakes. Cosine is associated with which letter, X or Y? X. Cosine is X. So what this means basically is X has to be negative. Well, where is X negative?
2 and 3.
Here and here. So we've taken care of this part. If we need the secant to be negative, where X is negative. Okay? Now, what about tangent? Tangent is Y over X. Right? So I'm gonna look right here in this quadrant. These are my only two options. In this quadrant, right here, X is negative, but Y is positive. If I do Y over X, will that be a negative number? Ooh, there's your winner. This is not a winner because down here, if you do Y over X, you actually get a positive. So the answer is quadrant 2. Narrow it down one piece at a time. Remembering that tangent and cotangent involve both letters. Sine and cosecant are Y. You look at Y. But Mrs. Fulbright got R. I never look at R because R is always positive. So R doesn't matter. I just need X's and Y's. So sine and cosecant are Y's, cosine and secant are X's. And you know that from your definitions. Remember, this is given to you, right? So it's right there. You can look right at it. Okay. Now we're gonna sketch. Here we go. Sine. You will need to know what the shapes are. So you need to remember that a sine has a hill and a valley. And then you need to remember to label. You get credit for the shape. You get credit for the labels. So the shape's up here. Now I need the labels. These are normally 1 and -1. But this time they're going to be 2 and -2, which means the amplitude is 2. These are normally 90, 180, 270, and 360, right off our circle. But what's happened, they have been divided by 1/3. So that's 90 divided by 1/3, which is 90 times 3. So this is 270. Now you can get all the rest of these by just adding 270. So 540, 810, 1080, if I did that right. So my period is 1080. Here it is. Okay. Y equals tan 2x. So first I'm gonna get my shape down. Asymptote, asymptote, squiggly line up through the origin. You need to be squiggling through the origin. Amplitude is undefined, right? No amplitude? Period. My asymptotes are normally at negative 90 and 90. You need to remember that. That's where they are normally. But what have we done? We divided by 2. So now they're at negative 45 and 45, which means a period is 90. Asymptote to asymptote. Negative 45 to 45. Adam, you okay?
Yeah.
All right. Be careful on this one. You know what a cosine looks like, but this one is going to be upside down. Why is it upside down? There's a negative out in front of it. So we're gonna have half the valley, and then a whole hill, and then half the valley over here. The labels for your cosine are the same as for your sine. So these are supposed to be 1 and negative 1. This time they're going to be a half and negative a half, which means my amplitude is 1/2. Remember, amplitude is always positive. These labels, look where they are now, where we cross top, where we cross bottom here, are supposed to be just like with the sine, right off our circle, 90, 180, 270, 360. That's where they're supposed to be. What have we done? Divide them by 2. So now the labels are at 45, 90, 135, 180. So my period is 180 degrees. Everybody okay with that? A lot of points right here. There's a point for the picture, a point for the labels, and then a half a point for each of these. So it's a lot. All right, now we need our calculators. And remember on test day, the only calculator allowed is a baby on the first part and your grapher on this part. So let's make sure we have our grapher and we're ready to go. 128.735 degrees. We're going to change that into degrees, minutes, and seconds. So all we have to do is DMS it, right? So second, apps, DMS. 128 degrees, 43 minutes, and 55.2 seconds.
44.
Oh, because I typed it wrong. Let me do that again, 128.735. I typed the wrong number. Yep, 44.6. Thank you. Gotta type it in right to get the right answer. All right, speaking of typing in, now we have a whole bunch to type in. Who remembers my advice to you on this section? Mark them, right? Either mark all the degrees or mark all the radians, but somehow distinguish. So which are our degree problems? A is a degree. Any other degrees? D is a degree. And F is a degree? No, C's a radian.
Is that not true to 180?
No, you don't want to do that. You want to take it just like it is, okay? All right, we ready? Here we go. We're gonna do the degree ones first. Okay, how do we do a cotangent? 1 divided by tangent. And again, it's 10,000, so negative 0.8693. Did I get that one right? And then I'm jumping down to D. Sine 52 second angle degree, 11 second angle minute, and 12 alpha plus 0.7900. Right, knot or something. We good? And then F, tangent, 153 degrees, 17 minutes. Negative 0.5033. How about that? Are we okay? All right, so now what happens? Now we go to mode and switch into radians. All right. B, second sine or inverse sine, 0.514. 0.5398. That was okay for answer B. Tangent, 18 second pi divided by 17. 0.1869. And then cosine 1.3. 0.2675. What do you think? Is that all right?
Yep.
Okay, number 10. 10 is easy. Don't overthink or overcomplicate it. We have a picture given to us, and our job is to find X. Doesn't that look like a word problem situation that we come up with? So what do? We write an equation. And what is the equation? Sine, cosine, or tangent. So look at it. Which one is it going to be? Sine. So sine 37 equals x over 12. Just like the flagpole, squirrel in the tree problems. So x equals 12 sine 37. Now, here's where some of us might mess up. See that right there? What does that mean? My calculator has to be in degrees. So remember, at some point, you're gonna switch it into radians. You gotta remember to switch it back. Because that's a degree. Okay, so I'll switch mine back. And I get 12 sine 37. Did you get 7.22? In a word problem, we put feet or something on that, but we don't know. That's it. B looks different, but it is exactly the same. It is a right triangle, it's upside down. Here's the angle I'm looking for. Which function is this? I need to write an equation. What is that? Opposite, and this is, so I'm gonna use sine again. So sine x equals 18/19. Oh, this is different. What do I remember when x is my angle? heard somebody say negative, you mean inverse sine? Inverse sine. So second sine 18 divided by 19, 71.33 degrees. All right, we got a course of 204. Be careful. 0 is
That's the top.
up here. And we go this way. So if you remember that, it's easy. We went 204 degrees. So won't 204 degrees be over here somewhere? And I just mark it with a big arc, 204 degrees, always starting up here, because that's 0. That's the starting point. Done. Is that okay?
Yeah.
All right. Find the exact value and the decimal value of this. All right, so we'll do, what does exact mean? Exact means do it by hand. Decimal means I can do it on my calculator, so let's do that one. We just type that right in. So tangent, second cosine, 2 divided by 5. You should have gotten 2.2913. Does that look familiar to you? Yes? Perfect. Now I gotta do it by hand. So doing it by hand always means drawing a picture. See that right there? That's positive. So when I draw this picture, I'm going to draw it in quadrant 1. This notation means you're going to draw an angle. Since that's positive, we're going to draw it in quadrant 1. And the cosine is 2/5. So now I'm going to do the Pythagorean theorem. A squared plus 2 squared equals 5 squared. Hey, are you two paying attention back there? Yeah. Oh shoot, I forgot to change the attendance too. All right, what did you come up with? Terry's still out. Sam's still out. Chase is out. Chloe's out. Is that Kira's back there? Crystal's still out. Emma's still out. Okay. What'd you come up with? Square root of 21? All right, now what do we want to know? We want to know the tangent. This is what we draw. This is what we want to know. So the tangent is root 21 over 2, and that is called the exact tangent. Okay, all right, here we go, last page. Test looks just like this, except there's only 3 word problems instead of 5. All right, so every single one of these word problems, I have a picture that looks like this. So I'm gonna draw a couple of them to get me started here. Oh, what have we got? A squirrel in the top of the tree that's 64.5 feet tall. What's that squirrel doing? He's doing what he's always doing. He's looking at a nut on the ground. And his angle of depression is 27 degrees. find the distance from the squirrel to the nut. So where do I put the X? Hypotenuse. Squirrel. Then I write an equation. What's my equation? Sine, cosine, or tangent? Sine 27 equals 64.5 over X. So X sine 27 equals 64.5. And 64.5 divided by sine 27. $142.07 feet. Easy. Now we got a pelican on the top of a lighthouse. And he spots a crab in the water below. The pelican is 93 feet above sea level. And the pelican is 202 feet from the crab. Where's the 202 go? Hypotenuse. Pelican crab, 202 feet. Find the angle. Is this another sign? So sine X equals 93 over 202. Don't you dare multiply by 202. What do? When X is the angle, we go straight to the calculator and inverse sign. $27.41 degrees. Is that what you got?
Yes.
We're almost done. You're doing great. Now we got an airplane. And he is 4,500 feet above the ground. The angle of depression is 16.3 degrees. How far is the airport from the point on the ground directly beneath the plane? So wouldn't that be this? This is the point on the ground under the plane. How far is the airport from that point? Well, this is not a sine. What's this one? Tangent. So tangent 16.3 equals opposite over adjacent. Multiply by X. And divide. $15,388.80 feet. This is rounded. Yeah, all the directions, so the word problems have said rounded 100. All right, here we go. Find the length of a shadow of a 19-foot flagpole when the angle of elevation is 59 degrees. Does that picture look okay to everybody? You're gonna solve that one exactly like you solved this one, right? It's the same situation. So go ahead on your own quickly, see if you can solve that. Did you get 11.42? So 1059 equals 19 over x, multiply by x and divide. Last one. We have a student looking at the top of a building that is 51 feet tall. And he is standing 200 feet from the building. Where do I put the 200?
Adjacent.
He's standing 200 feet from the building, that's the right here. What's this? That is from the top of the building. And when we measure distance, we don't generally go to the top of the building, we just go to the building. Right? And I'm finding the angle. Sine, cosine, or tangent? Tan x. Uh-oh, tan x equals 51 over 200. What do I do? Inverse tangent. And inverse tangent. (14.31 degrees). You agree with that? All right. Good job, people. Good work. I have a few papers to turn this off, and I got a couple papers to hand back. Not much, though.